I want to share. I'll just share it here. See if that works. So you put 12. Can you see my screen, by the way?
Yep, it's showing up.
So you put 12 volt in there, and then you also left a message. Is the ODOM sensor a 12 volt sensor, or is it a 5 volt sensor?
You'll need to look that up on the specs for that pickup sensor that you got. I think mine's like 9 to 36 volts for the input.
But are you using 12 volt?
I am, yeah.
And is there a benefit of using 12 volt versus 5?
Well, you'll need to see the data sheet on your sensor.
That's not the one I'm looking for. Inductive proximity sensor. So is this the same one that you're?
Yep.
The UR best 8 millimeter, blah, blah, blah.
So that one, the supply voltage is 6 volts to 36 volts.
Hey, Jeff. We were just doing a little business before we got started. Jeff, a couple things on that I wanted to just talk about was just go through some of the updates to the my bill of material and a wiring discussion, and show the wiring diagram, a little bit of a diagram and more like a wiring table. Anything on your list you want to cover today? You're on mute, I think.
Before we're done, I'm going to get some pictures. I took some pictures of my mini tractor front end that I got put together. So before we're done, I'll show those off. And other than that, I might make some more comments on power steering, but go ahead and do what you're doing here, and we'll come back to that.
Okay. So I have, you know, for me, some of the progress is about continuing to get clear on what are the parts and getting the parts updated. So my bill of material, which I'm in the milestone plan document in the sheet for my bill of material. So just tried to get really detailed in what are the actual things needed or going into or being used as input into my setup. I've also added this tab for wiring connections, and it's mostly, Matt, I would say, as an attempt to try to get really, I've made no bones about it. I'm trying to mirror as close to possible what you've done. I have the 8-channel relay wired up based on that video and able to, you know, send a test Python script to it to make all the relays click. I have been, let's see what else. At the same time, this is in an attempt to try to make the wiring clear and easy and not confusing. I've 3D printed this holder for, I can just, it's falling apart here. I mean, I've got a 3D printed deal here where the Teensy is effectively mounted, and then the what do you call this? A wire? I forget what they call that. Anyway, a wire board. And so I'm trying to get really, I want to run wires from that to that, and then everything else is coming into sensors, so it's not, stuff is not actually physically connected directly to the Teensy, but is connected to this wire bus. And so in an attempt to get crystal clear on what's going to and from, you know, I simply put this table together to say, hey, here's the Teensy, and it's going to connect to screw terminal numbers, and then those screw terminal numbers are connected to various things. What I was surprised by, Matt, is that you said you had connected your ODOM sensor to 12 volt, and I was just trying to understand, was there any benefit of being connected to 12 volt versus 5 volt? Or did you just point out that it said it's 6 to 36? So yeah, so you can't connect it to 5, right? It's got to be connected to 6 or greater. I guess I've answered my own question. This is where you say, yeah, Al, you've answered your own question.
And
Yeah, that's
as far as the interfacing on those, you can get a device. In fact, right there it says NPN on your, see in the description there, it says inductive sensor switch NPN, normally open. Some sensors will put out whatever voltage you put into it. So if you put 12 volts in, the output's going to run at 12 volts. But this is what's called an open collector device, which just has a transistor that pulls it to ground, which means you can, on your board, you can pull it up to either 5 volts or 3.3 volts with a resistor, or you can go in Arduino, you can say turn on pull-ups. And that way it's not, the sensor's not actually putting out a voltage. It's either shorting the voltage you have to ground. And that's why, you know, normally if you have a 5 volt board, you'd want to run your sensors on 5 volts, but this is a situation where on this particular sensor and on, say, a quadrature encoder, those just have the open collector outputs, and you can run them on whatever voltage it says you should run it on, but then the output pulls it down to ground, and you pull it up on your board to whatever voltage you want. So that's why.
Hey, Jeff, can you bump up your mic audio?
Well, let me just exit and come back in because it should be working. So I'll be back in a second.
So does it make sense to connect the ODOM signal wire to Teensy pin 17? Matt?
It can, yeah, it's an analog in.
Is my mic working now?
Wow, that's, yeah,
That's better.
Okay.
So Jeff, the way to read this table is, so I've got the ODOM sensor here, ground going to 12 volt ground, the power line going to 12 volt, and then the signal going to pin 17 on the Teensy. You see any issues with that? You're on mute, I think.
Oh, you can't hear me when I go.
Well, lip reading is an option, but not for me.
I don't see. Are you talking about your format, or about where those are actually saying they're being connected?
Where they're physically being connected. So any issues in your mind of taking the signal out of ODOM 1 into pin 17 on the Teensy?
No.
And you're saying I'm going to get either a high or a low there, or I'm going to get a voltage 0 to 5?
You're going to get a voltage from 0 to whatever your Teensy is pulling that up to. So if it's a 3.3 volt Teensy, that it's going to go 0 to 3.3 volts. Which you may have to go into your Arduino code and say, when you enable that pin for an input, you might also say turn on the pull-up to make that work. Otherwise, you should put an external pull-up resistor on there. And you can ask Matt what he did on his. I don't know how he's got his set up.
Yeah, I did an external pull-up resistor on that, and a capacitor to ground.
Okay. So from a documentation standpoint, you used a pull-up resistor, and you said one other thing, and a capacitor to ground.
Yep. A 0.1 microfarad.
What's the acronym for that? Is it MCF?
UF. Just UF, no MUF.
Just for reference, what did you use for the resistor value on that?
10K. No, I'm not saying this is correct. I'm just saying that's what I used.
But it's working, right?
Yeah.
And did you have to do anything special in the code like Jeff was thinking you might?
You can check in the Google Drive that has the setup, the pin setup for the.
Is it in the Teensy firmware?
Exactly. And under main.
In this CPP?
You can scroll down and see the setup.
Where did you put that up?
So you can see under wheel encoder, initiate a timer and attach interrupt there.
So Jeff, do you recall what command you were thinking you might?
Just right on the attach interrupt. It'd probably be under setup where you're under setup. Somewhere you say pin mode. Let's see, which pin are you using on that? Timer 1 initialize, timer 6. Up about 7 or 8 lines there where it says pin mode 21 output. It'd be that type of thing where you'd say pin mode input, steer angle sensor, reverse wheel encoder, timer attach. Or maybe you don't specifically have a thing where you say set the pin to an input mode, but it would be something where you'd say, I don't see anything here for inputs. But it would be something like you'd say pin mode, pin number, comma, input, comma, pull up or something. Oh, right above there it says set reverser switch, pin mode, reverse switch, comma, input, pull up. It'd be that kind of configuration. And I don't know if under wheel encoder, if that combination of commands sets it to input mode. Maybe it does. You could probably say set it to input mode with the input pull up and then go ahead and say attach the interrupt to it. But if you got the external interrupt or external pull up resistor, you don't need to do this in the code.
Do you remember what pin you used for the encoders, Matt?
Yeah, that pin is 6. So if you see attach interrupt 6,
Yeah.
that's the pin number.
So there must be other things going on with that attach interrupt command. Because he doesn't have the pin mode set. This must be doing that.
Well, by definition, the processor, when you first start it up, all the pins are set to input. So if you don't specifically say anything, it's probably takes care of that for you. So you may not have to specifically do it unless you want to put a pull-up on that. And I'm assuming you can use a pull-up while it's in interrupt mode, but I don't know right offhand. But since you have the external pull-up resistor, you don't need to do anything special in the code here.
Cool. So you used 6, and although this is a 5, not a... This is saying 6 is a PWM.
Also keep in mind, what Arduino calls a pin and what Teensy calls a pin might be two different things. You might have to look at a translate table to see on your thing on the right there, the little picture. Well, I guess that's what you're looking at right there. It says 6.
Yeah.
Now is that the Arduino 6 or is that the Teensy 6? You have to be careful of that. And I don't know how you determine that.
So is it, Matt, do you have any recollection? Is it analog 6? Is that 6 referring to analog 6, pin 20, or is it referring to pin 6?
Pin 6 as a digital input. So the grays, all the gray pins are digital inputs, or can be set to digital.
Yeah. And because you don't explicitly set it, it must be whatever that attach interrupt function is setting. Right? You're not getting an... well, let's look at the code for a second.
Back to that picture you had there where they said that pin was PWM, that just means as a special function, it's a PWM. Since it's a digital pin, it can either be an input or an output.
Mm-hmm.
And if you don't specifically tell anything, it will remain an input. So that's, the PWM is saying that's a special function. If you want to use that as a PWM, you can. So apparently, so if that pin 6 is the same pin 6 that Arduino goes by, then yeah, that should work.
Yeah, I was just pausing for a second to look at, and I don't need to keep you guys on the line, but I'm wondering where the encoder value is processed and what that code looks like.
So it's there's an interrupt and there's a timer. So every time there's an interrupt, it increments a count called ticks.
Yeah.
And then when the timer expires, then you know how many ticks you received for that given amount of time.
And so you're purely just counting the ticks in the timer. You're not actually processing the signal that's coming in. You're letting that interrupt just give you a timer tick, effectively.
Those are two different things. So one, it's counting a tick, and then I have a timer, so I know how many ticks I received in a set amount of time.
Mm-hmm. And I'm just wondering where would be an example in here. So you've got where is that from?
So when you attach the interrupt, you tell it what pin, and then you tell it what function you want it to send to, the callback function. And so that's the interrupt function that it goes to, and it just increments a tick counter every time a tooth passes that pickup sensor.
Right. So, I mean, the reason I was thinking through that is you're not actually reading an analog signal, right? It's just processing this interrupt function.
Yeah, you can think of it just as an on-off. Either the the gear is in front of the sensor or off. It's not really an analog message.
Yep, I got it. Okay, so that's been clarified. So I need to go get some resistors and a capacitor and hook that up. So that's been my activity. Plus ordering equipment and getting it held up in customs, needing to pay my duty, my tariff, to be clear.
So what was the story on that? They just simply sent you a note saying, "Oh, by the way, you owe money before we will release it." Is that what they basically said?
Yeah, that's the process. You get this happened to be coming from DHL was the shipper, and they give you a notification that says, "Hey, we're not delivering until you pay your fees." And you call up and say, "What fees do I have?" And they say, "Oh, well, the good news is this is a duty-free item. The bad news is it also has a tariff." And the tariff is calculated based on what's referred to as the HTS code on the commercial invoice. And so you go through argy-bargy of negotiating what's the least costly HTS code that you can plausibly get away with, and then you pay your tariff and they release it.
Was it a cheap part or something expensive?
$2,300 GPS unit from ComNav.
Oh.
So they wanted to charge me $700 in tariff. Yeah. Oh. So anyway, I got them down to $288. So it was a little bit more for an RTK GPS unit. It's the K703 model from ComNav.
You like that better than the SwiftNav multi?
I mean, you tell me. I have not had anything. I mean, what's our answer to what's the RTK unit that'll hold the fix?
Good question.
Yeah. So, do I like it better? No, I want something that holds the fix that's inexpensive. What's our answer to holds the fix and is inexpensive? Go ahead. I think you're on mute, Matt.
Yeah, it doesn't exist. We're still working on that part.
So, anyway. That's my so a little bit of 3D printing, a little bit of electronics, a little bit of getting my supplies in order, and my welder says my machine should be back today or Monday, so that's where I'm at. How about you, Jeff? What's going on in your world?
Let's see. I said I was going to show some pictures of my tractor, so let me bring up something here. So here is a top view of this is the frame here, and I've got this crossbar across here, and then there's two metal plates that come down, and this is the new axle that comes across, and on the end I've got these pieces that are go-kart steering units welded onto there, and I pre-cut this to give me a sharper turning angle. Otherwise, this arm that turns hits this and it gives you a hard stop. And it may have been far enough to turn it, but I didn't want to run up against a hard stop with whatever I'm driving it with, whether it be an RC servo or linear actuator. So I just pre-bent that basically, so I get more turning radius on that. And here's just a wider shot, so you can see on both sides. You can see the two are bent in somewhat, and this is how big the Super Servo is compared to that. So it will come up through that hole, so I've got plenty of room. What I want to do is actually weld something onto the axle and bring a bracket out to mount the servo on. So as the axle moves up and down, let me find that picture. So as the axle moves up and down like this, I want the servo to track with it. It'll be actually welded right on the back of this axle here. So the Super Servo will go back here. And this gives you another shot where here's the front subframe, and then here's that cross brace, and there's just plates coming down to mount this. So this is closer to like a real tractor or the garden tractors where they have the axle hangs down from the frame. And previously what I was doing, I kept lowering the subframe was actually below my axle, and I kept getting it lower and lower until it was only like an inch off the ground, so I could get all my steering angles, steering arms and everything to clear. So now I've modified it like this, and it's pretty close to the point where it should work. So let me go through the rest of the pictures here. So again, here's just a picture from the top. You can see how I cut the shaft here. I pre-cut the shaft at an angle and then welded the pieces on. And from the back, looking from the back towards the front, again, I got a plate bolted on the front, a plate bolted on the back, and just a single bolt there for it to pivot on. And this is the picture we started with, and there is size comparison for the Super Servo. And here's just another shot in from the side of the Super Servo just to see, again, I should have enough room this way to do it, and if I have to, it'll fit up through, it'll actually fit up through the frame here if I need to do that. And I lucked out. It turns out the space between the frame here is just the right size for the battery that I've got. It's like a 38 amp hour battery. Gel cell. It will fit down between there. Otherwise, I've got wood blocks here to keep raising the frame up. And before I used the wood blocks to lower the frame to make it lower. And I thought, well, if I had to put the battery clear on top of here, now it's getting quite high. So I've got so for the top of this rail down to this board here is like 3 inches. So I can now set the battery down. I've got a hole down in there. I can set the battery. So that's basically where I'm at on that. I'm to the point where I need to put a connecting rod from this arm and a connecting rod from this arm, and I think I'm going to bring them to the center here and tie both of them to the servo, and that way I'll get it'll be symmetrical on both sides. If I say turn it 10 degrees, then the Ackerman angle will give me the whatever angle it takes to do that. But if I set the servo to 10 degrees, that really is, I think that's the arc that the tractor will actually drive. So that's what I'm playing with right now. I just got to get that this weekend. I got to get that bracket welded on and get that bolted on and see what happens with that. So that's where I'm at on that project. And then I was going through the power steering stuff, and I was saying at one point, well, there's no sense going with the Saturn/Chevy version because then you have to buy this extra $50 module to make it work. But it turns out if you look on eBay, people for the Japanese ones, those do not have their built-in controller is not bolted right onto the steering unit. So when you buy them, they just sell you the steering column part, and if you want the controller, you have to pay another $50 to $80 to get that. So in reality, you're probably still better off going to the Chevy/Saturn one. So I went down the path of trying to figure out how to make this work, and I found enough information that they tell me what kind of bus it is that talks to it. And when I got all done, I just happened to pull up one of these things from eBay saying, here, the guy's telling you, he says, if you install this and turn it on, it will not work. He says, because the ECU doesn't receive information. So he says, you need a controller unit, and this device takes the position of the pot and sends it to the device, and then it will work. So I think what he's doing, he just has the pot sets your vehicle speed, and then that generates the vehicle speed message and sends it to the controller, and that keeps it happy. So that's something I can try one of these days. I'll have to figure out what the physical interface is and then figure out what the format of a speed message is and generate that with a microcontroller and see if that keeps the steering unit happy. And if we can get to that point, if we get to the point where it goes back to acting like a power steering unit, then I can play with the torque sensors and see if I can figure out how to get the, how to fake out the torque sensor message to get it to actually control the steering. And I was assuming that I was going to get a voltage off these torque sensors. And when I look at it, I think the one that Saturn/Chevy is using is not a voltage. It's some kind of, they're putting out some kind of a pulse to this. It's some kind of a transformer built in there. So it may take some more screwing around to get that to work. So at this point, it's just going to be a matter of, I'm going to have to get a steering unit and play with it and see what I can make it do. And so it's back to the original statement. This may or may not work. It just all depends on what comes up out of this. So that's where I'm at in that journey.
Have you found what's the cost of a Japanese steering motor that doesn't come with that control unit?
In general, all of those, they want more money for them, but then you can find ones that are down to, if you get down to the point they show you a wrecked vehicle saying, oh, I will sell you the power steering out of this vehicle, and you don't know if you're going to get the controller or not. So I guess on each individual basis, you could write to them and say, does this include the controller? And they may say, oh yeah, we can throw that in. Or they may say, no, that's going to cost an extra X amount of money. And the ones that were just listed as a wrecked car saying we're going to part this car out, I found some of those as low as like $45. But in general, they're up around $150, I think is what they were wanting for these things. And that may or may not include the controller. So you have to look at the actual eBay auction and say, you know, do they show me a picture of the actual stuff you're going to get? And a lot of times they just show the steering column with the motor and they don't show the controller. So I assume in that case, you're not going to get the controller. And then if you look at other auctions, it says, here's a controller that are for those kind of things. So it seems to be, just in general, they seem to want more for those. And I don't know if it's because people can't make the other type work or because there's just so many of them or what the reason is. It's just the ones like you guys already have seem to be cheaper than what the like the Toyota or Nissan or whatever. Kia Soul seems to be another one that's that would work. But just in general, they seem to have higher prices on those, and I haven't done enough digging into it to decide. So I'm still thinking if I play with the Saturn one, I can probably make that work, but I'll have to see what happens on that.
The other thing I noticed is you're quite a fabricator, man. You're just a Renaissance man. You can do software and metal and sensors. You got it all.
Well, I'm a robot builder. You gotta do all this stuff.
And do you have a MIG welder or a TIG welder or a stick welder?
Well, at home I do have a MIG welder. That's one of those flux core welders, but it's in my garage. I have to dig it out and put it outside and put a curtain around it, and it's cold outside. So I belong to this makerspace here in town, and they've got a TIG and a MIG, and they probably have some gas welders that I never use, but so I use their MIG welder down there to do it. And this last job I did, the welding just turned out beautifully. And before that, I was blowing holes through everything. And so I think I figured out the trick now. You open the door and it says, for this size of metal, set these numbers, and it just seems to work great. So that's kind of where I'm at on that in that journey is if I go down there, I can just walk in and the table's all set up. I just put it up on the table, set the numbers, turn it on, turn the gas on, and away I go. And when I'm done, I just put everything away and I can walk out. So that works out fairly well.
Cool.
And before I joined the maker space, my kitchen was my workshop. So I've got a drill press on a table in my kitchen, and I would use, I was able to build stuff, and that's why I used to build robots out of wood, because it's cheap and easy to work with. You can get wood out of the trash to build stuff with. And then eventually I decided to switch over to metal, and that's kind of how that turned out. And so as you can see on that mini tractor, that's how my skills have evolved. Now I'm to that point where we'll see if I can pull this off and make it work.
Looks very clean.
Hey Jeff, I was curious to know how you know the angle of your turning on your vehicle.
You mean how am I going to know
The steering angle.
Well, what I'm going to do is basically what we did on our big tractor is the same thing. You've got on our big tractor, it's got a hydraulic cylinder that turns, you've got your wheels like this, and the cylinder can turn it all the way against this hard stop and all the way to get this hard stop. So basically what we did, we ran it against a hard stop and called that 100%. And then what you do is you have to figure out what the angle of 100% is. And you can get out, we were talking the other day about getting out chalk and tape measures and putting all these lines on the parking lot and trying to figure out what that angle is. And then we later decided that at least Matt and I were discussing this the other day, that if you take your vehicle outside and put it up against the hard stop and drive it forward, it's gonna drive around in a circle in your parking lot, and then take a tape measure and measure the diameter of that circle, and you should be able to calculate back what that angle is, what that steering angle is. And in reality, it's not the angle of, you've got the two wheels on Ackerman. When you turn, one of them turns at a different angle than the other one, because they're both trying to stay on a circle. So in reality, what you want is the point in between, right in the center. And so you're really taking the average of that. So if you drive in a circle and figure out what the angle on one side is, and then drive the other direction to figure out, the diameter of that one, then theoretically in between those two should be your zero angle going straight forward. So it's just going to be a matter of you set it up mechanically, and then you run it to a known position, say against the hard stop, and then once you get to that point, then you can calculate back and say, here's the angle I think that is. Otherwise, you can just measure it. If say draw some lines on the ground, use a protractor. But if you're just measuring one tire, that tells you what one side of your Ackerman's doing, but not necessarily what the other side's doing. So that's why it's better if you can, actually drive the vehicle and drive it in a circle, and that way it'll tell you that's the center point. That's the actual value you're looking for. So if I say turn 10 degrees to the left, then that's the arc that it's going to follow as it goes around there. So so it really comes down to experimentation, I think, is the bottom line on that. You can come up with a list of ways to calibrate this, but I think it's just a matter, once you figure out the procedure, I think that should be fairly easy to do. So right now I'm just trying to get it so I can turn it left and right to some position that I think I want to be my maximum, and then go from there.
Thanks, that was informative.
And the other day, Matt and I were talking about calibration on various things, and not only can you drive in a circle and use a tape measure to measure it, if you've got your RTK GPS on there, you should be able to go in after you drive your circle, take your minimum X and maximum X, and it'll tell you the diameter of the circle. And you can either do min and max X or min and max Y to measure that. And then also you can calibrate your distance based on that. So if you've got RTK GPS, you start driving and then say, grab my encoder location. Say you're driving this way, you say at this point grab my encoder location and my RTK position, and then drive forward some amount and then grab it again. And that way, if you grab those numbers while you're moving, you're not taking the acceleration and deceleration into account, because that's something else that's you don't know for sure what that's going to do to you. So if you're trying to say you start up, you accelerate up to speed, and then you say, okay, grab this point, both the RTK and the encoder position, and drive some arbitrary amount, and then say stop, or you say grab the numbers again, and then you can decelerate down, and that way you're up to a known speed, and you can then you can measure your speed over that distance, and you can measure your distance over that amount. And that way you don't have to worry about what the acceleration and deceleration is doing to you at that point. So there's various things. If you just go back and look at this, there's different ways you can calibrate this stuff and use the sensors you've already got built in. So because we were talking about the fact that, when we first started off, we had chalk and we had tape measures and we had rulers and we had laser pointers and all kinds of stuff to try to figure this stuff out. And it turns out that, if you put all these sensors on your machine, you may as well go ahead and use them to your advantage. So one of these days we need to sit down and write up, here's some calibration procedures you can do to make this stuff work, and that I think would help out everybody at that point.
Absolutely.
I like your new steering setup, Jeff. That looks really tight. On that webinar from the IEEE Agriculture Robotics this week, they were reviewing the Vine Scout, a vineyard robot. And it was really interesting listening to the researchers talk about their design and how they have it set up. And one of the comments he made is that you need to have 1 degree accuracy on your steering. So they talk about how they first set up their steering system on their robot, and over time it would get looser and looser and looser, and then they would lose control of the vehicle. So he said, before you try to calibrate your steering controller, make sure that you have at least 1 degree accuracy control on the steering mechanism itself. So I've never heard a specific number to try to, reach, but that was the first time.
Did he say why he thought he needed 1 degree, where he came up with that number?
I think just experimentally. Yeah.
Because it seems like, the bottom line is once you start driving, regardless of how tight your steering is, if you're using, say, GPS or odometry or whatever, you're going to calculate where you actually went as opposed to where you're telling it to go. So I'm just curious if they had, some valid reason why they came up with that number. So
well, the way it sounded was that they weren't. It was really difficult to get the path controller figured out or calibrated when their steering mechanism was so loose. But he said if you could get 1 degree, then a PID would work. So what's interesting with robots is like if you it's where the biggest levers are in the system. You can have a very complicated vehicle controller, vehicle model, all this other stuff, or you can spend your effort and energy on making a really tight steering mechanism control. It's like hardware, electronics, or software. Where do you want to spend your time, and what makes the most sense?
And it really comes down to the fact you can't just put all your effort into one of them. You have to look at all the different levels and say, try to get each one as good as you can within reason. So
yeah,
I know I've had people
definitely a systems approach.
Yeah, I've had people tell me that they say, well, I'm trying to do an IMU and I'm trying to get a really clean power supply and I'm trying to do this and do this. And they say, oh, just throw a Kalman filter at it. I said, well, but if you're generating garbage to start with, your filter's going to get rid of a lot of that, but you really have to start with, reasonable data to start with. And that's kind of the same thing on my mechanical system. I built several steering systems and none of them have been tight enough really to use yet. And this one I'm hoping will be close enough that it's, whatever this turns out, I'm going to go with it. So, and then move on. It's almost warm enough to start driving outside. So I need to get something that actually moves.
I feel the same way. So, anything to comment on today?
No, it's interesting when Jeff said you put in garbage values and you get out garbage values. I was reading this article about the Boeing crashes, and one of the things that they mentioned was the new software that they made was trying to make sure that if the aircraft is going, if the distance of the aircraft from the ground is too low, if it's too low, then the aircraft would try to go down or make its nose, go down so as to increase the speed to go back up. And one of the things that they suspect was that one of the sensors, there were 2 sensors in redundancy, and one of the sensors or something, there were 2 sensors and one of the sensors was giving garbage information. So the pilot was trying to take or make the plane go up because they were just, starting to take off. And because of the sensor, the computer was making or asking the plane to go down to make it faster, but they were just trying to take off. And the pilot could there was a switch that he could turn off, or he or she, whoever the pilot was, they could have turned the computer input off, but they couldn't, and they kept getting garbage values, and that led the plane to unfortunately crash in an ocean. But yeah, sensor values, and I mean, software's going to do what it's asked to do. Sensor values, that they matter. Yeah.
Colin, anything else from you today?
Well, what I decided to do is exactly what you guys are talking about. So I'm working on control for mobile robots. That's one of the courses that, by the way, I registered for a degree in computer science. So I decided I don't want to have this Coursera stuff. We pick some things and drop some things. So I'm now doing a degree in computer science, and one of the subjects is modern robotics is one of the subjects that I'm picking up, and mobile robots is one of the other courses that I'm doing. So I fully follow what you guys are discussing, and because I looked at the whole thing myself, and I felt that buying motors here and buying stuff here, when I am not in the domain in terms of leveling up my knowledge, I'm going to leave a lot of stuff that I have to depend on others. I realized it's not just knowing how to program, it's more than that. So I hope I'll be able to complete the programs. It's a 3-year stuff, so it is going to take me 3 years to complete. But I'll be working on my projects. When I get to a stage where I feel that I now need to be working on start working on the project, then I'll be doing so. But I'll be having my first exams in September. So that's all there is to me, nothing more.
Thanks, Colin. How are your crops?
We'll be harvesting next month.
No, that's exciting. There you go, Matt. There's a reason.
Get on it. Colin, when do you plant again?
In 6 weeks from now.
6 weeks from now. Do you have any interest in setting up a Raspberry Pi and a web camera and recording your plants when your tractor drivers are out driving around?
Oh yes. It's one of those things. Anything to do with agriculture, if I can lay my hands on it and how to do it, those are the things I want to do. Remember, I'm not after the degree paper to get employed. Who employ an old man like me? But I'm after what I can get in order to do what I want to do. So I'll be very much interested if there is a way of doing it.
Do you have a USB web camera?
USB web camera? No, I probably need to buy that if necessary.
Okay. Yeah, so we can just use like what would be good for you for your farm is to start recording data, image data, and the perception team can start using your data to run machine learning and on those data sets. So we could just start out with like a Raspberry Pi and a USB web camera. And then what we would do is on your tractor, we would just take the web camera and point it towards the ground. And then when your tractor drivers are driving through, it just records the images. It records a video in a ROS bag. And then with those with that information, we can start processing it. We can start practicing. But that would be useful for the perception team, and it would also be useful for your farm because we'll start to understand basically things like what your weeds look like. And then in the future, we can add mechanical removal or spraying. But maybe we can work with you over the next couple weeks to get ROS loaded on your Raspberry Pi, and then get a USB web camera, and then we just create ROS bags. That's how we collect the data. But that would be a really good exercise. You get to learn about ROS, how to create ROS bags, and then we get to start to collect ag data, image data from your farm. We could do it during harvesting
Right.
too. That would be cool too. Like if you have fruit on your trees, basically this
Yeah.
is just think of like a little data collection kit. Basically you may have like a little battery and a Raspberry Pi and a web camera. So a pretty small little box.
Yeah.
And you point that camera
You-
like and then
Yeah,
you would point the
Go ahead.
you just
Go ahead,
like for oh yeah, so like in your orchard you just point the camera towards your trees, and then Kalyan and the perception team can start to do yield estimates for you, being able to identify what fruit is in your trees and make estimates like that. We point it towards the ground and we can start to make decisions whether it's a plant like your wheat or corn or maize, and then what weeds are growing. Does that sound like a fun project?
Yeah. It sounds quite like a fun project. You are aware that the government acquired one of my farms, just as they did for the white farmers. They acquired my farm in 2014. I had macadamia nuts there, and I was told that the plans are there for them to return the farm back to me. But this month we are planting mangoes, and then in
Okay.
September we are planting lemons, because from a climate change perspective, lemons have got long taproots. Therefore, you need to make sure that you have constant cash flows coming in. Not only will you have constant cash flows coming in, but you also have foreign currencies coming in, so that you are not restricted on how on obtaining foreign currency, applying for it from the Reserve Bank. You open a Nostro account. So those are the things that I'll be doing. So what we are talking about is for scaling in the plans that I have, things that I need to do. One of the other subjects that I have on my degree is machine learning and neural networks. It's part of the things that I'll do. But for now, we are doing mathematics for machine learning. We are doing mathematics for machine learning now. But in the third year, that's when we do machine learning and neural networks.
Okay. These data sets are very important. One of the difficult things about agriculture is that generally you get one planting per year. So if you want to identify a trend that takes five data sets, it may take you 5 years to collect the data to start to predict these trends. That's why it's important, even though you may in your third year be learning how to process this data, it's okay and it's good for you to collect this data as soon as possible so you can get year-over-year trends. And I can help.
I'd lost you. Yeah,
Okay.
I'd lost you. What we do, remember, we've got 2 cropping cycles in Zimbabwe, particularly on this farm, because we irrigate. So as soon as we come out of summer, we go into winter cropping where we irrigate. So we can take data twice a year.
Good. That's helpful. That'll be a big advantage to you and your farm. The sooner you can start collecting data and the number of years, the more advantage you'll have.
Yeah. No, I'm interested, Matt. You just got me as to what I need to do.
Okay.
Matt, I think if there was a standard data collection, bill of material, so to speak, I think that would be useful in a lot of places. I mean, I'm thinking of the same, well, to keep us all informed of what you craft for capturing it, because I think, again, it would be useful for others.
Yeah, anyone. The more data we get, the faster we learn, and then the year-over-year data is the really interesting things. If you look at disease, how disease progresses through a field, like a vineyard or an orchard, it's absolutely amazing to track and watch how it flows through. It's a living organism, and so the patterns are fascinating. So you can, by identifying those trends and seeing what works to keep your pests and your diseases under control, it'll save you money and give you healthier plants.
Cool. Matt, anything else you want to share in the last couple minutes?
That's all I have.
I have a question for you, Matt. What's the ideal? So you mentioned you use video, you capture video as raw specs for this data collection. Is video the ideal data format to do this, or do they take?
Yeah.
Do we take pictures, or is there a convention from?
That's it. Yeah, that's a great question there, because you can generate a ton of data. So generally, for processing large data sets, it will be images. So you won't, you'll just take snapshots of those images, frames, whatever, how many frames per second, whether that's 5 frames per second or something like that. And then from that, then those images get annotated. Kalyan is working on a data processing pipeline, but basically we will collect frames at a certain rate. We'll bring those in, you annotate, human goes through and says, this is a weed, this is a plant, and then from that, we use that to train the models. But your question is, what's the data rate? And it's different. So like for on-road vehicles, if you're going 60 miles an hour, it's different than farming where we may be going, 5 or 4 miles an hour. And I don't know what that data set is. Juan down in, he is in Argentina, and he's been collecting some data. So it'd be interesting to see if he's got an idea, or if there's maybe a research paper out there what the right data rates are. Good question.
Thanks. I remember Juan. We met him at the AgPod Challenge.
Yeah.
I had a chance to connect with him on LinkedIn again.
Cool.
So I have a question for Al. Your GPS that's being held hostage, did that come from China or did that come from somewhere else?
Shanghai, China.
Okay, I was just wondering if they're also putting tariffs on stuff coming from other countries. I thought it was just from China where they were doing it. But I was thinking that unit you're talking about, I was thinking that was coming from somewhere else than China. But
the DHL customer person said it was duties and tariffs are different. The tariffs are linked to the trade war, and anything coming from China is attracting tariffs at the moment.
And the problem with duties is everybody that ships says, oh no, this is free, it's a gift or whatever, and eventually they look at that and say, well, no, it's not, and then they come back to you and expect you to pay it. So that's been an ongoing thing for a long time. But up to this point I've never had a problem with anything. So maybe I'll just stop ordering anything from China specifically, and if I can buy it from the U.S., I'll try that. So.
Yeah, it's just a word to the wise to just talk to your shipper, because it's all about what they put on that commercial invoice.
Yeah.
Okay, guys, have a great weekend. Thanks for taking time out to have a chat, and we'll talk to you again at least next Tuesday, if not before.
Okay.
Have a great weekend. Bye.